So how do you know how many significant digits something has? Okay, the important numbers. Okay, so sometimes I will just give you measurements. Okay, if you look over here, we have a bunch of measurements. And then I told you how many significant digits or significant figures are in each measurement. So 312 has 3 significant digits in it. 0.020 has 2 significant digits in it. So what does that mean? How do you know if something is a significant digit or not, depending on how you wrote it? Okay, so there are some rules, and you can probably figure them out from looking at these measurements, what the rules are. First of all non-zero digits are always significant figures. I just wrote SF. Okay, so all numbers that are not zero, so 3, 1, 2, that has 3 significant digits, all of those numbers are significant. Okay, now that's the only one that's all non-zero. So I'm going to get to the zero rules because those are the most difficult. Zeros before the first non-zero are not significant figures. So what I mean is zeros at the beginning of a number before the first actual number or non-zero are not significant. So if you look at 0.020 here, these first 2 zeros they're not significant. Those are considered placeholder zeros. The 2 here and this 0 are significant. So zeros beforehand, so this one here, zeros before that 7 don't count. Okay, the 0 before this 8 doesn't count. Zeros before this 2 don't count. All right, so zeros before the first non-zero are not significant. Sandwiched zeros are significant. So what that means is if there's a 0 between 2 numbers or 2 non-zeros. So this example here, got a 9040. Okay, the 0 between the 9 and the 4 is significant. 0 on the end in this case is not. This only has 3 significant figures. 0 right here is 0 between the 2 and the 5 in this number are significant. Okay, so zeros in between are significant. And then if you're looking at the ones at the end, there is a rule that tells you when they are and when they're not. Okay, so let's review really quick. Zeros before the first non-zero don't count. Sandwich zeros do. And zeros at the end, it depends. What does it depend on? If there is a decimal somewhere, if there's a decimal somewhere in the number, then the zeros at the end or to the right do count. Okay, so I want you to use these rules to figure out how many significant digits are in each of these numbers in example 7. Okay, try those and then check your answers and let me know if you have questions. Okay, so A only has 2 significant digits. Remember, zeros before the first non-zero do not count. B has 3 significant digits. That 0 on the end does count because there is a decimal place somewhere in the number. Okay, it's right here. There's a decimal. Okay, if there's a decimal anywhere in the number. 9.20 has 3 significant figures. There is a decimal, right here. So the zeros at the end do count. This one only has 2. Okay, the zeros at the end don't count in this case because there is no written decimal. And this one, oh, that's wrong. This one has 5 because there is a decimal. The zeros to the right count. Well, and that would make these ones here considered sandwich zeros, or there are also zeros at the end. Those do count because there is a decimal. So all those zeros at the end are going to count if there is a decimal. All right, if you need more practice with this, there will be some in the homework. All right, so this should hopefully be a review. Scientific notation. We're going to use really, really big numbers in this class and some really, really small numbers. If you think about it, we're talking about molecules. Atoms. If I want to know how many atoms are in something, it's going to be a very large number. So we have to be able to express those correctly. So just a really quick review of scientific notation. Writing things in scientific notation should look like this. Some number in decimal form times 10 to some exponent. Okay. A couple of notes. That number in the front should always be between 1 and 10. So if you're trying to figure out how many times you got to move your decimal place, always move it so that you have one number in the front of your decimal place when you're writing in scientific notation. So if you look at examples A, B, and C here, example A, I've got 9.3 in the front. I moved the decimal place all the way to go to 9.3 because that is between 1 and 10. B is 5.114 because that decimal place gets me a number that's between 1 and 10. And C, I move that decimal 3.34. Again, it's a number between 1 and 10, or in this case, -1 and -10. Okay, but your front number needs to be between 1 and 10. Now then, how do you figure out that exponent in the scientific notation? Well, instead of trying to remember if it goes left or right or what that means, because some people end up switching them in their mind, if you have a negative exponent, that means it was a very, very small number. And if it's a positive exponent, that means it was a very, very large number. Okay, so if I was converting A here into a scientific notation, I would move the decimal. Okay, now there's no written decimal, so you assume it's at the end. How many times to make my front number 9.3? So I would go 1, 2, 3, 4, 5, 6, 7. So I move the decimal place 7 times. So that means it is 9.3 times 10 to the 7th power. Now I have a positive exponent because this is a very large number. Okay, B, I moved the decimal 5 times to get it to 5.114 times 10 to the, now I wrote -5th because this is a very small number, so it needs a negative exponent. Okay, so keep that in mind, give these a try to get these into scientific notation just to make sure that everybody's on the same page. Okay, I have each of these written out, so make sure that you did them correctly. You might even have a scientific notation button on your calculator, and that's fine. Go ahead and use that. One thing I wanted to point out here is how to count significant figures when you're in scientific notation. Actually, it's super easy when you have numbers in scientific notation. It's anything to the left of the multiplication sign is significant. So this first one has 4 significant figures. B has 3 significant figures, and C has 5 significant figures. So anything on the left side of a scientific notation number is considered significant. Another thing to point out is when you're putting a number into scientific notation, you should keep the same number of significant figures. So this last one is a really good example. If I look at this number and I said, how many significant figures does this number have? You would be like, well, 2, 1, 0, that's 0 sandwich, 6, 7, those are all significant. There's no decimal place written. So this has 5 significant digits. The zeros at the end do not count. Okay, so my number in scientific notation should also have 5 significant digits. That's why I put just 5 numbers here, times 10 to the 10th. Okay, if you need help with scientific notation, please come see me in office hours.